Welcome to the Fuel Pulse Show podcast, where we talk about all things fuel for all kinds of people. I'm your host, Erik Bjornstad. I'll be your guide through the ever-changing world of fuel. And today it's time for another episode of Fuel Pulse Show Back to School, a series where we do short, condensed discussions of the major important topics of fuel maintenance and fuel care. Now, earlier in the series, we did 2 episodes on fuel sampling. We talked about how to fuel sample, where in the tank is the best place to pull samples from. And we talked about how to handle those samples so that you get the best and most useful test results for your purposes. In today's back to school episode, we're digging into interpreting the test results from the testing done on those samples that you submitted. We want to touch today on how to interpret the different kinds of test results with respect to what different kinds of results might be telling you about the condition of the fuel and whether or what further action might need to be taken. So let's dive in. Now, there are plenty of options for different tests to be run on stored fuel samples. Many of these options are ASTM tests, like those listed in the slate known as D975. If it passes all the different D975 tests, there's no reason that the fuel won't work properly if you use it. But that doesn't speak to what might happen in the future. And that's where some of the additional non-D975 tests come in. These predictive tests. So we're going to try today to cover all the main bases by going through the major tests that you'd be most likely to consider for your stored fuel. So let's start with the D975 tests, which are often included in test slates or test panels offered by testing companies like ALS or by service companies like Bell Performance. If any of these test results are off, whoever's doing the test will generally note that in the test results report so that you can determine what you need to do next. First, the distillation test. Now, D975 lists a 90% recovery temperature. And the specification says that the 90% recovery temperature for your fuel sample needs to be below a maximum benchmark of 288 degrees centigrade. If it falls above that, then technically it's out of spec because it doesn't meet that D975 requirement. Now, that kind of situation could likely be caused by either contamination with a heavier fuel, which would raise that temperature, or it could be from evaporation degrading in storage, where lighter fuel components over time would evaporate out of that fuel, change its composition, skew this 90% distillation temperature upwards until it exceeds the 288 degree maximum. Now, if you were to use that fuel, your engine's going to run, but it's going to have poor combustion qualities. The engine's not going to run as efficiently as you want it to. Okay, API gravity. API gravity is a basic test because it's simply an index of density, although it's actually inversely related, if you will. The lower the API gravity number, the heavier the fuel. If the API gravity is too high, i.e., if the fuel is too light, then that can be caused by contamination with a lighter fuel, like gasoline. If the API gravity number is too low, which means the fuel is too heavy, that too can come from contamination with a heavier fuel, but that can also come from that thing we talked about before, from that long-term evaporation in storage. Either way, if you try to use the fuel, it's probably going to run, but it's going to cause engine operation problems that aren't going to be ideal for you. Okay, cloud point and cold filter plug point temperatures. Now, these are cold weather gelling indicators, and they are listed in D975, but they don't have mandatory specs assigned to them because ASTM recognizes that different parts of the country have different requirements, and they can't set one value that's going to be best for everybody. So it is useful to know these values. You want to note what that temperature is for your fuel, because as you go into the fall and in the winter, you're going to be paying attention to the weather forecast, and you're going to want to plan to put anti-gel like cold flow improver into your stored fuel when the upcoming forecasted temperatures are predicted to drop to within 10 degrees of your fuel's cloud point, which means for most fuels is going to be when the temperatures are forecast to drop below 30 to 32 degrees. Okay, flashpoint. The D975 specification wants it to be above a certain temperature. The D975 says it has to be a minimum of blank. If the flash point is below that minimum, it's likely because there was contamination with a lighter fuel, like let's say gasoline. Now, if you try to use it, you can run into all sorts of engine and fuel system issues. Cetane index, another one of those combustion properties. Cetane index is actually done by a calculation from the density and the distillation temperatures. Now, D975 wants your cetane value to be at least 40, right? If it's too low, you're not going to get the optimal or best kind of combustion or operation in your engine. So you want it to be above 40. Total particulate. Total particulate addresses one of the two tests that are listed in a specific test that's actually in D975 called water and sediment. So total particulate is sometimes a test that's broken out from those because they want to give you one test that tells you how much particulate's in your fuel. And they typically will then pair it, as we will see, with a test that just measures water. Total particulate is the test that measures only particulate content. And that is important because if you have excess particulate in your fuel, it can cause all sorts of problems in your engine and in your fuel system. Since total particulate isn't actually in D975, there's not an ASTM specification on this. However, if we know that water and sediment, which does have a specification, if we know that that specification, that limit is 500 ppm, then let's say if you have a total particulate of 3, then that would mean you would have to have at the same time on that water test that's going to go along with it, you'd have to have close to 500 ppm just of water in order for both of those together to be equivalent to a failing test. And then the last one, water by Carl Fisher. Water by Carl Fisher is actually the industry standard for measuring total water content in fuel. That means it measures all forms of water. Every kind of water that's in the test, or every kind of water that is in the fuel is measured by water by Carl Fisher. That means free water, suspended or emulsified water, and also dissolved water. D975 does not give a water limit since D975 leans on that combo water and sediment test. But many engine manufacturers do have their own standards or their own thresholds. And generally speaking, they like it to be below 200 parts per million water. Okay, so you've got those tests. And so we go from those to now talking about some of the important non-D975 tests that we would classify as predictive tests. So with that, we have the stability tests, oxidative and accelerated stability. These are two versions of the same test. They're accelerated test methods where the method forces exposure of a fuel sample to massive amounts of oxygen at elevated temperatures to try and speed up degradations. The stability tests are predictive tests because they're giving you a window into what's likely to happen to the fuel over a period of time. They just use a specialized test method to try and compress the time. And so the lab report that you get is going to tell you if the stability result is too high. Now, if it is, one thing you do have to keep in mind is a high stability result does not mean that the fuel has elevated particulate in it. What it does mean is that the fuel contains enough molecular precursors that if they're left to their own devices over time, they are going to be more likely to form sediments and more likely to degrade the condition of the fuel in the future, more likely than a fuel that has a better stability score. Okay. Then the last one is the microbial testing. Now, in a way, microbial testing is descriptive because it's trying to tell you the level of microbial contamination that's in your fuel right now. That's the definition of a descriptive test. But microbial testing is also predictive because if you have elevated microbial counts and you don't do anything, there's a very strong probability that they're going to cause problems in your fuel at some point in the future. So you definitely don't want to have an elevated microbial contamination. Okay, so those are some of the tests. Last thing to consider, what should you do if you have elevated results on these? Okay, so for certain of them that we started off with, flashpoint, distillation, API gravity, there's no simple chemical fix, if you will, to make those go back in line. You can try diluting the fuel with fresh high quality fuel to try and bring those back in line. But if those don't work and if the problem is serious enough, then it's possible you may need to get rid of the fuel. You're just going to have to make a business judgment call on whether it's worth it for you to do that. Okay, what about cloud point or cold filter plug point? Well, those aren't things really that you can fix in terms of changing the temperature property of the fuel. But what you will do is use that information to tell you when you need to add anti-gel. Okay, what about cetane value? Well, if your cetane is too low, you can add a chemical cetane improver like supertane. Now, how much you're going to need to add in order to raise it, how many numbers, that depends on your fuel. Stability testing. If your stability testing comes back poor, that is a sign for you to add stabilizer to the fuel. Easy fix. If the microbial test comes back with indications of high contamination, then you need to use biocide to kill those microbes. If the water and sediment or Carl Fisher or total particulate tests come back failing, that is a sure sign that you need to do fuel polishing. It's also not uncommon to have multiples of these tests coming back failing at the same time because of common factors that affect multiples of them at the same time. So let's say you have both a failing microbe test and a failing particulate test. Your solution for both of those at the same time would be to do fuel polishing, and you would want to add both biocide and chemical stabilizer during your polishing process to knock out those problems together. And so that's going to do it for today's Fuel Pulse Show Back to School review of things to consider when interpreting test results that you get back for your stored fuel samples. If you liked what you heard and you haven't done so already, feel free to subscribe at your podcast platform of choice and leave us a review if you can, because that really helps other people find us. So until next time, I'm Erik Bjornstad, thanking you for joining us, and I'll see you next time at the Fuel Pulse Show Podcast.